All right, we're going to solve trig equations here. You did this in Math 3. Oh, I need to pass it out. Okay, and here we go. We're going to annotate the steps, and then we're going to do these examples on the back. I printed that last notes packet. Wanted to get it to you right away, not realizing that it was going to be so quick and easy for me to get these done. Okay, there we go. Thank you, thank you, thank you. Ooh.
We don't have this many people this year.
I know.
There's only 2 of us. We have like 7.
I know. So cool.
Wait, what?
Shake one for you, one for Megan.
Yeah.
And put the others in the paper. I didn't want to count. It takes too long.
What do I put these?
1, 2, yes.
What do I forget this? I'll pick them up later.
Okay.
Okay.
Sorry.
Ow. I keep biting my lip. It hurts.
You need canker sores.
Okay. Huh? That's what it feels like. Oh, that's why. Okay. The first thing you want to do is you want to look for the type of angle that the question is asking you for. In Math 3, I remember students getting confused and always doing their answers in degrees, and I marked them down. So, it's only degrees if the instructions say 0 degrees to 360, okay? That will mean degrees, okay? It's radians if you see this. So if this is in the instructions, you're going to give your answers in radians. If that's in the instructions, you're going to give your answer in degrees. If both are in the directions, you have to give both. Okay? Or both. Okay. Guess what? It's got to be both. And homework. But on the test, it'll be one or the other, I think. So, okay. Determine all angles. Determine all quadrants. Okay? So that's when you might want to use one of those shortcuts, like all students take calculus. Or for me, I always look at visually. I use SOHCAHTOA and I use that to figure it out. But you need to figure out all the quadrants. It's usually going to be 2. Sometimes it is a quadrantal, and sometimes it'll be 4, but I think that is unit 2, not unit 1. Okay, so I'm going to write usually 2 quadrants. Not usually quadrant 2, usually 2 quadrants. Usual 2 quadrants. Okay. Then you're going to sketch your triangle. You guys are pretty good at that. You're going to mark the reference angle, x-axis. You're going to use SOHCAHTOA just like before. Then you're going to identify the measurement of the reference angle. This is where you use those special right triangles. Okay, so if you don't remember them, you might want to put them on a Post-it and then put them on there or write them somewhere on there. But that's those ones up there with the 1/2, the root 2, root 2, the root 3/2. Okay, so your answers, your reference angles are always going to be 30, 60, 45, or it could be a quadrantal, 0, 90, 180, or 360, or 270, okay? Or if it's in radians, it's going to be the pi/3, or pi/6, or pi/4, or any of the quadrantals, like 0, pi/2, pi, 2 pi, 3 pi/0, okay? So, but I'll show you guys how to get those. Then the last step is you have to find the angle in standard position. Okay? And this is a typo right here. You're always adding or subtracting 180 or 360, pi or 2 pi. Okay, it's always these quadrantals you're adding or subtracting to get the angle in standard position. You'll remember it when you see it. Okay? You guys ready for an example?
No.
Yeah.
No? No?
Just kidding.
Okay, so let me show you guys. Flip your paper over. We have that one.
Wait, just knew is that 90 was supposed to be 180?
Yeah.
That's come on, she said it.
Yeah.
I wasn't listening.
Okay. These two are the two hardest. Okay. This one we did do in Math 3, but it's been a while. We did this one in Math 3. Where do you guys want to start?
Hardest.
For the hardest? Okay, so let's look at C or B. C or D. Let's go for D.
The hardest goes.
Okay? And then
Hardest.
if it's too hard, we can always go back and do one of
Just
these
fake
other
Jack.
ones.
I'm over it.
Ooh, that one is hard. This one might be a little easier for you guys to figure out. Duty? Duty. This class is too fun. Okay, so this one is pretty darn tricky, huh?
Too much loud.
So first, we're gonna look at the instructions and figure out, do we want angles or degrees? Okay. Jordan, in group 5, can you tell me if we want degrees, radians, or both?
Degrees.
Okay, how do you know?
Wait, yeah, it's both,
Why?
because there isn't a degree sign there pi.
Oh.
Oh, and then
Oh,
the instructions.
I get the new
Come
package.
on,
You notice?
Oh yeah, you guys have
Big
extra
Steve.
copies. I only gave you 3.
Jack has extra copies. Remember you?
I got 1,000.
Mhm.
He's
There we
good.
You take this one?
He's good.
Okay.
Step.
So here it tells us degrees. And
Slow mo. Too slow mo. Walk the.
this one tells us radians, so we need both. And I'm glad that we're doing both. Okay. It also tells us what quadrants are possible. What quadrants are possible? Okay. Oh, it's like Friday on Thursday. Good golly. Okay. So I have to now decode this statement to figure out what quadrants we're looking at.
Mm.
This tells me which ones to look at, and then this one tells us how to fine tune it. Okay? Jack,
Would it be 2 and 4?
would it be 2 and 4? Why?
Because it's between 0 and 360, and it's negative.
Okay, so
2 and 4
0
would be negative.
and 360. Okay, and then you said something about negative?
Yeah, quadrants 2 and 4, the only ones that can have negatives in.
Okay, so 2 and 4. This one has negatives.
No, I said 2 and 4.
Oh, 2 and 4. This one has negatives.
I thought the value was both negative, so it'd be positive.
Oh, that's for tangent and cotangent.
Oh,
So it could be any of those 3, right? So now I have to decode it. We know it's not in 1, okay? But I need to look at secant and I need to decode that. So we look at the triangle, okay? X, Y, and R. Secant is the what? What over the what? R over the X.
Oh, yeah.
Okay, is the R,
Oh.
what do we always know about the R? So if this is positive, what must the X be?
Negative.
Negative. So which 2 quadrants have negative X values?
2 and 3.
2 and 3. Okay, so I'm going to draw my triangle here and here. Okay,
Oh.
reference angle should be an easy one. Where do I label that one?
It's always here, isn't it? Okay, which makes this the opposite. Do we know the opposite right now?
No.
No, that makes this super hard.
Indeed, indeed.
Okay. So, but I do know how to get some information, right?
Yeah.
Okay. So, I'm going to give you guys another decoding helpful hint. When it says without a calculator, that means that we are using special triangles. Okay? So, the special triangles all have those special ratios. What are our special ratios?
As far as pi, or
As far as side lengths.
like √3/2 and like √2.
Oh, yeah.
1/2.
Okay. So, we know it has to be a 1/2 of √3/2 or √2/2. Okay? What's the r always when we're looking at our special triangles? 1. So we know that the r here is 1. Okay, we know that x is negative, so the negative's in the denominator. But this fraction does not look like one of those ratios that you guys just mentioned. Which means that it was, and someone uncomplicated the fraction. Because it was a complex fraction. So if I put a ratio here, then I'm going to have a fraction down here, and you have to multiply by the reciprocal. Okay. And they may also rationalize the denominator. Okay, so what ratio do we think might have been here? If this is the result when they simplified.
Oh, √3/2.
√3/2. So I want to just double check to make sure that's not a typo. Okay, but it has to be that one because there's only one with the √3. Okay, so if I were to simplify this, it would be 1 times multiplied by the reciprocal, and I would get -2/√3. Could this still be that?
Yeah.
What would someone have to do to turn this into that?
I don't do this.
Is there a radical in the denominator here?
No, not there.
Where is the radical in that one?
On top.
On the top. So what do you do to a fraction to get a radical on top? Multiply by what?
Reciprocal.
√3.
Oh, not √2.
I heard, I think it was Shelby say it.
Oh.
You multiply it by √3/3. Okay, so -2 √3 over, what's √3 times √3? 3. So was that a good educated guess?
Yeah.
Okay, so what's the x value then that I'm going to put on my adjacent? -√3/2. So if that's -√3/2, we already know that the hypotenuse is always 1.
Is this going to be on the test?
Maybe not this hard. What's this one? 1/2. And what's that
The
one?
1/2 come from?
-1/2. So if this is √3/2, it's in the triangle that has a 1/2.
Oh,
that make
so
sense?
okay, so.
So you just
it's
finish
all
the
special things.
triangle, because
Okay.
once we know this, you can go backwards and get this one.
Got it. Okay.
What's this one?
60. No, it's 30.
It's 30.
I said 60.
Smallest ratio opposite the smallest angle, so what's this one? 30. And in radians, what's this one? Pi over what? 6. And this one?
5/6.
Pi over 6. Now, we did a lot of work and we're still not done. We have to now find the angle in standard position. This is just a reference angle. So how do I find that angle? In degrees first. It's easier for degrees. Subtract 30 from what? 180. Do you guys agree? So, not 360, 180. Okay? So we know that this one here is 180. And I don't want that much, so I take the 180 and I subtract 30, and what do we get? 150. Good. Okay, and then I need this one. And standard position. How do I get that one? Add 30 to 180. Yep. And what's 180 plus 30? 210? Okay. You guys are good at those with degrees because you did them so much in Math 3. But the radians were harder. How do I get that one? Here we used 180, right? What's this one in radians? Okay, I want to use pi over 6, but it's not pi over 6. It's pi. So if I want a 6 in the denominator, it's 6 pi over 6. Very good. So what am I going to do here to find the first one in quadrant 2? 6 pi over 6 minus pi over 6. And what do we get?
5 pi over 6.
5 pi over 6 is the first answer. Very good. I'm going to do the other one over here so I'm not writing so low. Okay, and this one? Yes.
Yeah, let's put some of these on that.
Okay, so this is what I want you to do because we don't have a whole lot of time left. I do want you to, this one will be on YouTube.
Okay.
Message me. Let me know if there's questions you want me to add to a YouTube video and I'll get them to you over the weekend. Okay? That was the